presenter will speak up, and then to encourage good recording, please keep your mic or phone muted unless you are participating in the discussions. If you are not using phone call, please mute and unmute your phone by pressing *6. Right. With that, please welcome Dave Glover to bring up our session today, IoT Data Architecture. Dave, your session is yours.
All right. Hey, thank you very much. Hey, thanks everybody. Thanks for the introduction as well. As it was mentioned, please feel free to ask questions. I will do my utmost, my best to keep the chat window. So do feel free to put any questions into the chat. You can also use the hand up, but I may not spot it. Or if you've got a really burning question, then feel free to use the audio and ask me a question. I'm super happy with that as well. So the main thing, if you've got questions, feel free to ask. My name is Dave Glover, and I have a role at Microsoft called a Cloud Developer Advocate. And I have a focus on the Internet of Things. And as you can spot behind me, if I just move over a fraction, you'll see the Opera House behind me, Sydney Opera House behind me, and I'm based in Sydney, Australia. You might be able to figure that by the accent as well. So this session here, we're going to look at IoT data and really the flow of data through a system. Now, obviously, there are devices that capture data, and we're going to look at some of the considerations for those devices. And then we're going to look at cloud architecture. Now, I suspect that more folk on this call will probably be more cloud-centric. So I'm going to cover off some of the device stuff. The session's about, I don't know, a third on devices, third on cloud, and then a third on demo. So I'm going to that's kind of how roughly it's going to split up. So don't feel if I'm going into devices stuff and you're thinking, gosh, I'm not a devices person. I've really got no idea what you're talking about. I promise you that we'll get much more into the cloud side as we go through the session. Hopefully the slides will be popping up. They're being displayed. And so just to kind of give you just a sense of this as well. Now, this session here is a bit of a mix of a session that I've recorded, plus a number of my team that have recorded around what we call the IoT event learning path. And there are 5 sessions there. So if you want to find out more in each of these areas in more detail, then just go onto YouTube and go search for IoT show space ELP, and that stands for Event Learning Path. And if you do that, you'll find there are 5 sessions up there. They've got a session there which is more about, hey, what does it actually mean to connect a device, a real device, and connect it up into the cloud. The session we're going to do here is kind of this optimizing data communications and maximizing ROI. It's really around IoT data architecture. That's what the session is really about. There's a session there which is looking about IoT and the use of AI and machine learning models. There's another session there on big data, and there's also a session on edge computing. So typically it's about moving intelligence to the edge, often used for camera capture, for example, on production lines, looking at quality control or safety or things like that. So do keep an eye. So go check out on YouTube, and you'll find those up in the IoT show ELP. Now, the agenda for the session here, we've got a bit of an introduction to IoT, and it's going to be quite abstract. And then just in terms of broad kind of concepts, and then we're going to look at, so what does it actually look like when it comes to Azure, and what are the IoT services there? We're going to look at what we call stream processing, and I'm going to show you a little example there around Power BI and data visualization. And then depending on time, this may be a stocking filler, but depending on how we get on, we're also going to look at something called IoT Central. Alrighty, so in terms of the things that are kind of driving innovation, if you think about the things that are really happening at the moment, there's a huge amount of innovation, and of course there's a huge amount of commoditization. So things are getting cheaper. So if you think about the cloud, we've kind of got almost unlimited quantities of compute and storage and memory and all the things that kind of go with that. We're now also getting to a vast number of IoT devices that are connected to the cloud in one way or another that are able to send data into backend systems. And of course, there's been a huge amount of, I guess, a huge number of breakthroughs around machine learning and AI models, and being able to either run those AI models in the cloud, or what you also see increasingly happen of deploying those AI models to the edge. And I mentioned that just a moment ago. So for example, you might have a production control system and you've got a camera and it's watching boxes go past on a production control and just checking the quality of those. And in that case, it makes much more sense to go and process that on the edge, because it really would not be feasible to take every image of package that you're taking and shipping that image up into the cloud to then process it up in the cloud. That would soon become unmanageable, expensive, and a huge amount of data. So lots of scenarios where kind of it makes much more sense to be able to do the intelligence on the edge, and that's kind of the rationale behind it. Just often it's just not feasible to go and put all that data up into the cloud to run against a machine learning model. And there's also these things that you might have heard about called digital twins. And this was also, I think, was known as spaces or digital spaces or something along those lines previously. So it's now known as digital twins. And the whole idea behind that is it's the idea of being able to map the complexity of the physical world, in which case this could be factory, for example, it could be the equipment inside the factory, it could be the people inside that factory, and the relationship between all those things inside this factory, or a city, or a farm, or whatever it is. It's a kind of general idea. So digital twins are really about mapping the complexity of physical world into virtual models to kind of make it easier to address more complexity. Now, the scenario that for this talk, I've picked a smart factory, and you've probably picked up on that already because I'm sort of using those kind of themes. So the first one I'm going to be talking about is kind of monitoring an HVAC system. So an HVAC is a heating, ventilation, and air conditioning system, and you find them in factories and buildings. Almost certainly you've got one in your home. They're everywhere. So it's kind of everyone understands they're kind of controlling the environment. I'm going to look about machining tools, and I'll explain a bit more why as we kind of get through the talk. So things like lathes, which are used for kind of forming objects in a manufacturing process. I've already mentioned production line quality, where you might, for example, use a camera and local machine learning models to go and look at the, just check on the product line quality. And raw materials, and the reason I picked raw materials is often raw materials, certainly in Australia, are often stored a long way away from anywhere, and they don't have good internet access. So kind of what are strategies around dealing with things that might be kind of away from the general access to the internet? So I thought the first thing I'd start off with is the kind of the general architecture of an IoT solution. So it's kind of made up of three fundamental things. You got things that generate data. So there's sensors. So for example, it could be a sensor that's in a factory or in your home, monitoring lights. It could be monitoring temperature. It could be monitoring humidity, all those types of things. We've got insights. So we build insights, and insights are based on the data that's coming up from those devices, typically coming up into the cloud, and then we're going to build some sort of insight. I'm going to talk about that in more detail. And then the other end of that is actions, and we base that on insights. So for example, we might be able to determine that everybody has left the building, in which case you might want to turn the lights off or turn the heating down, or there might be things that you just want to kind of automate inside a factory, in a building, in a city, in your own home for that matter. So that's the kind of general idea behind this. So what I'm going to talk about now, and I'm going to talk about this in much more architectural terms of the kind of considerations, and then I promise you I'm going to talk much more about what this means in the world of Azure. So I'm going to talk through about three scenarios about how devices are connected and some of the kind of implications of that. So we have devices or sensors or whatever it is. We have a device that might be sitting inside a factory, and this device is normally, in this example here, this device is quite capable. And by capable, I mean it's got enough CPU resources, RAM resources. Typically, these devices are quite constrained, and it has enough resources to be able to make secure IP connections to the cloud. So it can send data over TLS, for example. And it can negotiate certificates and negotiate security, all that kind of stuff. So those are kind of the first category of devices, devices that are capable enough to be able to make connections to a cloud. They've got Wi-Fi in them, or they can connect over Ethernet, or whatever it is. And those devices, they can send messages. And messages broadly fall into two categories. We've got telemetry messages and alert messages. So telemetry message might be, hey, look, the environment, I'm just measuring temperature, humidity, and pressure in the light, for example. Alert messages might be, hey, look, something's happened in the factory, and this is important. We need a different way of being able to kind of action that alert message. These are different priority. So you often, when you're building systems or when you're building devices, you tend to think about your messages, and that broadly fits into telemetry and alert messages. Now, the other thing that's an important consideration is data types and network bandwidth. So if you're dealing with simple data, and again, I'm just picking on temperature, humidity, and pressure, small amounts of data, you would normally just go and serialize that as text. And often you just serialize that into JSON and just ship that up into the cloud, and you would process it up in the cloud. And you think about lots of backend systems nowadays support JSON natively. So databases tend to handle JSON super well. Stream processing, again, they will mostly understand JSON formats. So it's a really useful thing. But you might have other data types which don't kind of lend themselves so much to being serialized into JSON. So for example, you might be capturing the odd image, and it would not make sense to base 64 encode that so you can send it up as text. So you'd normally go and take that image and you'd use a binary serialization. And there's things like Google Protobuf and stuff like that, which you can go and serialize that data. And it makes for a very efficient way of getting data from a device to the cloud. So it makes it super easy. Now, the other thing that if you're a device developer, or if you're looking to deploy IoT devices inside your organization, when you're talking to vendors, you should make sure that these devices, when they're sending data, have got metadata, so kind of data about the data, because that'll make your life much easier in the cloud when it comes to processing that data. So if you've got data about that message, so for example, you might want to know what the serialization format, is it going out in JSON, or is it going out in Google Protobuf? Is this an alert message? Is this a telemetry message? What's the serialization format of that message? Super important when you want to be able to deal with that data later on. You say, okay, this JSON data is serialized in version 1, and I need to transform that data into version 2 schema that my database is expecting. It's that kind of concept. The other things that we have is these kind of gateways, and these fall into two kind of areas. So we've kind of got what we call field gateways. Now, the first devices I mentioned, they're quite capable devices, but often you'll find, and it's very industry specific, that you'll find devices have been in factories, for example, for maybe 20 years. Really well before that people start thinking about using internet protocols. So typically these devices, they don't have enough CPU, they don't have enough memory, they can't form a secure connection to a cloud gateway. And so what you normally do with that is you go and put in a field gateway, and you normally put that field gateway, for example, in the factory next to those constrained devices. And then this field gateway would kind of act on behalf of that device, the constrained device, and then be able to ship that data up into the cloud on behalf of that device. The other thing that we have is the concept of cloud gateways, and you would normally use these to bridge other networks. So I've already mentioned before, so I mentioned the example about raw materials would often be stored offsite away from a decent internet connection. But what you might find is that you can get that data from those remote locations over LoRaWAN. And LoRaWAN is a protocol which is really geared to long range, low power. So for example, you could get data maybe 20 kilometers from one location to another location. Then maybe you might have a network point there. get that data there, and then you could get that data onto the gateway and into the cloud. So things like LoRaWAN, Sigfox, particle networks, and things like that are other ways in which you deal with this type of data. And then the final one I want to talk about, and I've kind of touched on this already, is this kind of idea of intelligent edge. And the example I'm going to use is the lathe. So you see these in factories, they spin around super fast, and they're used for kind of molding or drilling out components in the manufacturing process. And so we've got a situation here with this lathe. So let's say this lathe, a ball bearing breaks in the bearing, the support for this lathe that's spinning around, and that you need to be able to respond to that data really quickly. Otherwise that lathe might just spin off into thousands of pieces. And this is another example where the time value of the data that this IoT solution is generating might be really low for most of the time. 99% of the time, the value of the data coming off that lathe is completely interesting. But of course, when there's a problem with the lathe, then that data suddenly becomes really interesting. So the whole concept behind this is that you can stream process that data, say, yep, business as usual, the data is normal, nothing interesting to see here, and except you might start getting vibrations, in which case you say, right, you need to be able to respond to that really quickly in milliseconds. It doesn't make sense to be able to send that message all the way up to the cloud, and then the cloud decide what's going on, some sort of intelligence in the cloud to say, yep, I think you should stop. At that stage, it's probably too late because that lathe has spun off into thousands of pieces. So that's a concept of why you want to be able to deal with local intelligence, but particularly around some IoT solutions can generate a lot of really uninteresting data. And it just does not make sense to ship all that data up into the cloud. So normally what you do is you'd stream process it. You say, look, I'm going to aggregate this data, and every 5 minutes, I'm going to send out the average, for example, to the cloud, and I'll log that somewhere. Now, the analogy I like to use is what's called the reflex arc, and I'm sure we're all familiar with that. You go and touch something hot, and you would have learned at school that you touch something hot, what happens is the first thing you do is you pull your hand away super quick. And what's actually happening is that message is going down your arm into a node in your spine. And it's actually the node in the spine that's got the intelligence to say, hey, I need to pull my hand away super quick. Otherwise, I'm going to burn myself. And that's exactly the same concept here, where you've got local intelligence. So in the case of peripheral nervous system in the human body, we've got these nodes in the spine, which are geared towards really low latency, being able to respond really quickly to protect our bodies, really kind of the general concept behind that. Okay, so that's all I'm going to touch on the devices side. The next thing I'm going to talk about is kind of what's going on in the cloud. And then fundamentally what we do is we obviously want to be able to store that data. But it's really important to think about that data and where we're going to store that data. And I'm sure you've heard these terms before, but warm path and cold path. So warm path is typically data that you want to be able to work with kind of fairly immediately. You might want to use that for interactive reports, for example. You want to be able to grab that data super quick. But a lot of IoT data is not used for reporting, or it just might be used for audit purposes, for example, in which case you would normally go and put that into cheaper cold path storage. And it's super important to think about that data, because you might start off with a project which has got maybe just a few sensors connected to it, and then suddenly you've got hundreds or maybe even thousands. Now you're having to start to deal with a lot of data flowing through a system. And what I have seen people do is they're going to put all the data into one data store. So we'll just put all the data in one big SQL database. And then what happens is, of course, that SQL database starts to get really big. And of course, the performance starts to get really bad. So you've got users there who want to be able to query that data for reports. And suddenly they're now competing with a whole lot of audit data. So those are the kinds of things you really need to think about your data in terms of what's interesting data for reporting, and maybe there's just a window. Maybe there's just a 2-week window for that data, and then I'm going to ship that into cold path. But you definitely need to be thinking about your data. And look, you'll almost certainly need to transform that data as well. As that data is flowing into the system, I mentioned things like schemas. Schemas change. You might have a device from one manufacturer is using a different schema with a different version number, and another manufacturer doing a different, but the same kind of idea device, but using a different schema. And whenever you need to transform data, or often you need to calibrate data as well. So you kind of do this transformation. And we've also kind of got this idea of stream processing. So you potentially have a lot of data flowing into the system. And again, in that individual elements of that data actually may not be that interesting. And you want to go and aggregate that data, let's say into a 5-minute window or a half-an-hour window, depending on the type of data. Excuse me. So in that case, you want to do the stream processing. So, okay, here comes a whole lot of data flowing into my system, and on the fly, I'm going to aggregate that data because I'm actually more interested in the average values that are coming off a sensor that ultimately I'm going to be storing. I don't need to know every 5 seconds or every 10 seconds what that data looks like, because it probably looks about the same. But maybe over half an hour period, that data starts to look a bit more interesting. And you can also run rules over that and make decisions on things like that. And of course, you want to be able to do reporting and stuff like that. And then the whole idea behind this is you want to be able to integrate that with backend systems. So you got this data flowing through the system. You want to be able to integrate that into backend systems. And ultimately, of course, you want to be able to drive some potentially automation back to the sensors to control the factory or your house or your smart city or whatever it might be. And of course, with the world of machine learning, we've now got this cold path data, which we can not only use for audit, but we can also use for machine learning. So that's the kind of idea behind that. So you've now got access to this data where you can now start training models, and then maybe deploy that model into the cloud, or maybe deploy that model to the edge, to a device. Okay, so now I'm going to talk a bit more about what do those kind of concepts. So in here, I talked about cloud gateways, stream processing, devices, and things like that, without kind of saying what they look like inside Azure. So this is going to be about making this thing much more concrete. Okay, so we've got things. And I've talked about those that could be directly connected devices and those capabilities. There could be edge devices, they could be gateway devices, they could be cloud gateway devices. Now, the cloud gateway in the world of Azure is this thing called a service called Azure IoT Hub. And IoT Hub is an internet scale bidirectional messaging engine for IoT. So it's a mechanism by which data can flow up from devices into the cloud, into Azure IoT Hub, and you can also send messages back down to these devices to be able to control those devices, the behavior of those things. Now, inside Azure IoT Hub, we also have this concept of digital twins, which I'm going to talk about in a bit more detail shortly. And we've also kind of got this concept of what we call message enrichment. So as data is flowing through from the devices, you almost always want to be able to enrich that data as it's flowing through the system. To give you an example, you might go and deploy an IoT device somewhere into a smart city or into a factory. Now, it's highly unlikely that when you created that device and programmed that device, that you know where that device is going to be located. So what you would typically do is you say, okay, this device has an ID. Now, when the telemetry comes from that device into the cloud gateway, I want to enrich it. And let's say I want to enrich it with the longitude and latitude, and maybe the name of the location where it's at. Because you wouldn't know that device, you wouldn't have that data when you kind of manufacture that device. You'd know it after it's been deployed. So you've got these ideas of message enrichment. Now, the other thing that goes on with IoT and IoT data is that you most likely have a whole range of different sensors that are sending data up into Azure IoT Hub, excuse me. And you almost always need to partition out their data. Say, hey, look, these are all the messages that are coming from the HVAC monitoring system. I want to partition those out to some location. These are all the security messages. These are all the lighting messages and things like that relating to a lighting system or the security monitoring system. So you almost always want to be able to partition that and separate out that data into different locations. And once you've kind of separated this out, we have this concept of stream processing, which I'm going to go into more detail. But as I mentioned before, This is the kind of idea of taking lots of data flowing through a system and being able to often aggregate that data. And in the world of Azure, we've got something called Stream Analytics. There's Databricks you might be familiar with, and Azure Functions. And the whole concept behind that is you can then separate out that data into different locations. So the data is flowing through the system. That data that device itself hopefully has some metadata about that message, and you're enriching that message as it's flowing through the system. Then you're partitioning it. You're almost always stream processing it just to reduce the amount of volume of data. And then you want to make decisions about where you want to put it. So audit and things like that, you typically want to go and put in cheap storage. So often things like Azure storage is the obvious place to go and put that. You go and put it into blob storage or things like that. Maybe if you're going to want reporting, you might put it into Cosmos DB or Azure SQL. If you're doing data warehouse, you might be wanting to push it into SQL Synapse. Maybe you're going to be doing some more machine learning, so you perhaps push that into upstream and you go and push that through Databricks. Or maybe you want to put that onto an event hub. So you kind of got this idea here. In this case, you've got BI. You're going to be able to do some reporting on that data that's sitting in Cosmos DB. And maybe we've got actions. So we wanted, for example, that data is flowing into another event hub. It's gone through the stream processing into that event hub, and we want to push it through a logic app. And if you've played around with logic apps, you'll appreciate that they're low code, no code solutions where you can kind of build a business process. And as that data is flowing through, you can then make decisions, and it gets you away from having to code up everything. You can use logic apps as a high-level way of basically being able to map out a business process. And of course, you'd want that to be able to send a message back to IoT Hub and then back down to the device. Hopefully this is going well. Do feel free to ask questions. I am keeping my eye on the questions as well. Okay, so I mentioned message enrichment. So this message that's coming up from a device, so this is the shape of this device, the shape of this message. It's a bit of JSON, and you can see that we've got temperature, humidity, and pressure. And you can also see that there's some metadata about this message. The application ID is called HVAC. The type of message is telemetry. It's formats in JSON, and it's version 1 of the schema. And this data is now going to go up into IoT Hub. And then for every device that's defined that has a connection into IoT Hub, there is what's called a device twin. So a device twin is a JSON document. So every device has a JSON document associated with it. And in this case, inside that JSON document, there's a section in there called tags. And you can see in here that the tags, I've got deployment location, and inside that I've got name, I've called it Sydney Factory, and I put the longitude and latitude. So there's a question there. I will get onto that question. That's a great question. Yeah. I'll touch on that in a moment, actually. Thanks for that question. Okay, so that's about the concept of message enrichment. And you can see here, as the data's flowing through, I've now got this enriched message where I've got the original message plus I've now got a message with longitude, latitude, and the name. So suddenly that data is now becoming more useful upstream as I'm processing that data. Now, we also have the concept of message routing. So now that message is coming up through the system, I can then start making decisions about, okay, so I know this message here because you can see in the middle here, the app ID here is HVAC. And you can see I can go set up rules inside IoT Hub to say, hey, look, if I've got a message that's coming through the system whose app ID is HVAC and the type is telemetry, then I want to go and send that off into an event hub called the HVAC telemetry event hub. And that would be the same for messages, security, lighting, and event hubs. So inside IoT Hub, there is this rules-based mechanism by which you can look at the data as it's flowing through, make decisions about that, and then basically route or partition off that data into different locations. Okay, so I'm going to hopefully answer your question about where you might use one, because they are very similar. Okay, so now I've got the data partitioned. So I've got data living in my cold path for audit purposes and things like that. remember I put data into the HVAC telemetry event hub and security and things like that. So now I want to do stream processing. So the way that you tend to think about these, so you're quite right, these sort of do this, they sort of do similar. And I'm going to split these out into different areas. So if your organization or if your skill set is more SQL centric, so you've got a lot of database core skills inside your organization, then Stream Analytics is a great solution, because when you look at it, it's very SQL-like in its syntax. It's very much select from, group by, those types of things. So it's very SQL centric, and for a lot of organizations, that is a good place to start. Most people, or a lot of organizations, have got people with database skills who understand kind of how you'd go and structure a query against data. The difference, of course, is you're querying data on the fly. Databricks is much more, if you're an organization who's much more kind of data science centric, and you've already got people inside your organization and you have invested in skills and your Databricks and you're using it for machine learning, then it probably makes more sense to go and use Databricks. Now, the other way, and the third option I put up there is Azure Functions. And I put this down, if you're kind of more developer centric, you'd probably look at Azure Functions. Now, there's another way in which you can slice this, and that's to do with stateful and stateless. So Stream Analytics and Databricks are more stateful stream processing. So for example, they kind of understand the concept of windows of data. So you might say, hey, look, I'm interested in this data and I want to aggregate it over a 5-minute window or a half-an-hour window or a 1-day window. They understand state. They understand all the data that's flowing through there, what's making up the average, and as more data is coming through, I'm building up my average. So they understand state. Azure Functions typically don't. So you would normally, some data would come through a function and you would do some processing on that. You maybe do some transformation. Now, look, there are ways in which you can use functions for more stateful processing. And for example, the way I've done this, if I wanted a really cheap solution, is what I do is I put the messages into a storage queue, which is very cheap, and then I have an Azure function which wakes up every 5 minutes, reads all those messages out of that queue. I then run a link query against it, and then aggregate it myself, and then run the results of that. So the question was, where is the state, the 5-minute window stored for Databricks? Okay, I'm going to show you an example around Stream Analytics, and then you'll get a bit of an idea behind that. And we kind of got this, we've got these endpoints, and I've kind of touched on this. And so hopefully it kind of gives you a bit of a sense of where you might use different stream processing. So you've got to think about stateful versus stateless, and what's the skills inside your organization. If you're a more data-centric, SQL-centric kind of organization, Stream Analytics is probably the way to go. If you're more data science, Databricks is the way to go. If you're more developer focused, then Azure Functions provides a great solution as well. Now, the other thing I want to just touch upon is stream processing. So inside Stream Analytics, you can not only create cloud-centric stream processing jobs, but you can also export those and ship them down to the edge, where you might want to go and do local stream processing on the edge. Using that lathe as an example, where that data is not very interesting and you just want to process it locally and just maybe send up the aggregate values. Okay, so hopefully that's the end-to-end. So we've got devices or things that are generating data. We've got insights being built in the cloud. In this case here, we've got IoT Hub, which is its internet scale, bidirectional, secure messaging engine. We've got data enrichment. We've got data partitioning. We've got stream processing. And then we make smart decisions about where we want to go and put that data. Cold path, think cheap storage, maybe for training machine learning models or audit purposes. And then other data sources, which may be more useful for reporting, machine learning, data analytics, etc. Okay, so what I'm going to do now is just go through a bit of a demo and give you a bit of a sense of how this hangs together. And I just need to change the screen that I'm sharing. Okay. So what I've got here is I'm signed into the Azure portal, and what I'm going to do is just go through and just give you a sense of what's going on. So what I've got here is I've got this thing called IoT Explorer. Now, this is a utility that you can download from GitHub. You just go search for Azure IoT Explorer. And what this is going to do is it's going to show me the messages that are currently being sent from a device that I've got sitting in the house here. And you can see that this device has sent 178,000 messages. And I'll just stop that processing coming through. And you can see in here that, so you can see this is basically the model, the body of this data coming through. So I've got the temperature, that's the body message in here. And then remember I talked about metadata. So this is the metadata that's come from the device. And you remember I talked about stream and message enrichment. This is the data that I've enriched these messages with. So in this case here, it's got New South Wales, Parliament. This is the location. And I'm also adding in weather data from Open Weather. Okay, so that's the data coming up, and it's going up into IoT Hub. And so inside, this is a resource group I've got set up for this demo. And I've got Azure IoT Hub sitting here, and this is the service I mentioned, so bidirectional. And I've got a number of devices inside this IoT Hub. And what I'm going to do is just go into the device in question. And so I'm going to explore this. You've got connection information and security information about this device. And you remember I mentioned a thing called a device twin. Now, every device has a JSON document associated with it. And you can see, you remember I mentioned about this tag section? This is the tag information about this device. And this is going to be used by the message enrichment process. So basically, when that message goes through, IoT Hub will reach out to the device twin and grab that data and then add that to the data stream. Now, I added this data in here manually. I literally went into this JSON document and updated it. You, of course, would normally go and build an application that you would give to your end users. And then say, hey, look, here's a user interface, and you can go through and tag these locations. And then your application would update these device twins. Okay, so that's that part there. So we've talked about the device and the device twin. So the next part I want to go looking up in here is this thing called message routes. And the first thing I want to talk about is, just make sure I know where I'm going on this, message enrichment. So message enrichment here, what that's doing is it's got a reference to the device twin. Now, you remember there was an area inside that JSON document called tags. And this is literally the syntax to get at the tags. And you can see it was the hierarchy for that JSON was under deployment location, and then underneath that name, and longitude, latitude, and weather location. And all that's going to do is add that to the telemetry as it's flowing through. And these will be added as JSON properties called name, longitude, and latitude. And then the next thing I've got is these things called custom endpoints. So what I'm going to talk about now is this concept of partitioning. And you can see down here, I've got a custom endpoint here, which the namespace is going to be called is Factory 10 Eventer. So I've got an event hub called Factory 10 Eventer. And the hub inside that is called HVAC telemetry. So basically what it is, I've got and I'll show you in a moment, that's service I've got set up there. It's event hub, and inside that I've got a hub. And it's going to go out to this HVAC telemetry event hub. And then I've got routes. And then routes are rules. And you can see if I go and click on the HVAC telemetry one, you'll see that there goes that rule. So you saw that in the slide. So there goes with the app ID on that metadata that's come from that device is called HVAC, and the type is called telemetry. And basically what's going to happen when IoT Hub sees that, it's going to say, I know about you, I've got a rule for that, and this is where I'm going to route you. I'm going to send you off to this endpoint called HVAC telemetry. Okay, and you'll see down here, in here, if I can spot it quick enough, for the event hub, there goes the factory 10, and down through here, there goes the event hub, and then you'll see inside here, there goes the HVAC queue. So that's where that message would end. Okay, so the next thing that's going to happen is I'm going to be pushing this through stream processing. And I'm going to be using stream analytics. So in this case here, I've got my stream processing job. And you basically define your inputs. So I've got my input over here. And you can see, surprise, surprise, one of those inputs is the HVAC telemetry. And you'll see that's come from that event hub called, so the event hub service is called Factory 10. We saw that the hub was called HVAC telemetry. And I also have some weather data, which I'm also enriching the data as it's flowing through this query. And then I have outputs, and you can have multiple outputs. In this case here, I've got the concept of an alert queue. So, hey, look, messages are flowing through this. I'm going to send messages which are super important to an alert queue. And I've got some sort of business process which kind of deals with that. Another one, another endpoint for this data, which is going to be the HVAC Cosmos DB endpoint. And then I've got another one, which is storage. And I'm just putting that data into storage, cheap little storage. And then the other thing I've got in here is a query. And you remember I said that stream analytics jobs, the query language looks very like SQL. And so I'm just double checking there aren't any questions. Don't think there are. So this is very much like SQL. Now there was a question about how do you go and determine, let me just set it. Okay, so the question was, okay, I'll keep going. I'll probably get to that at the end. So down in the SQL query, you have this thing called a tumbling window. Now you can see I've set this tumbling window to be 1 minute. Now, normally 1 minute doesn't make sense, but for demo purposes, if I set it to anything longer, you don't see the data coming through, so it doesn't look that interesting. So you normally set it to 5 minutes, 10 minutes, so whatever makes sense for the business application, for the business. But you can see it's very SQL-centric. So I've got a select in here. The from is going to be from the HVAC telemetry event queue, hub queue. Got a timestamp on there, so for ordering purposes. And then here I've got where the metadata called HVAC, the version of that schema is version 1. So this is only going to try and process schema version 1 data that's coming through the system. And then like SQL, you've kind of got your group by. So that's the kind of concept here. So as I said, stream analytics is very SQL-centric in its nature. And then you can see down below here, I've got various outputs as well. So again, very SQL-centric. What I'm going to do is that the telemetry up here, if you look down here, so I've got a select from telemetry T. So again, very much what you see in a SQL database. I'm going to do an inner join. I'm going to join it on some weather data that I'm grabbing from OpenWeather. And you can see the same thing I'm doing for that data is going into Cosmos DB. This one's going into storage. And you can see this one here is going into an event queue. So that's kind of how this works. And if I scroll down here, you can also look at what we call a job diagram. And this job diagram is a visual representation of this. So you can see, hey, look, there goes the data that's coming in through from my event. I'm not pushing this through the telemetry. I'm pushing this through this query. And you remember then I've got a couple of joins, inner joins. So I've got an inner join on that data that's coming from this query. I'm now doing an inner join on that telemetry, enriching it with, in this case, temperature data, so environment data, and it's going to Cosmos DB and got storage. So that's the kind of idea. So you get quite a rich view of the data that's flowing through the system with stream analytics. Okay, so the next thing I want to show is now we've done that, what I want to show is how you can get at this data from Power BI. So Kind of curious, do feel free to put this into the Q&A. Has anyone used Power BI before? Do feel just to chip in there if you've been using it. So what I'm going to do is I'm going to be using Power BI to grab that data from Cosmos DB. And I've got the connection string in here. This is loading up, but would like to. Cool. So it's quite interesting. So what I'm going to do is give you kind of like a 5-minute whirlwind view of creating a report with Power BI, and you'll kind of get a bit of a sense of it. So remember, the data is flowing up from my sensors. It's gone up to IoT Hub. I've done some partitioning. I've moved the data for the HVAC system into a queue. Then I did some stream processing on that, and then put that data into Cosmos DB. So remember, that's the kind of the flow of this data. So what I'm going to do now is click on that, and I'm going to go into the what's called the Power Query Editor. Excuse me. And I'm going to look at that data. Sorry, I did jump a little bit. What I didn't show, I do want to go back over here. Come back. The last thing I want to show is back into Cosmos DB, the data explorer for Cosmos DB. And I'm going to, so there goes my factory 10, and the data goes into these factory items, and the data is actually that data there, and there goes the data. And you can see that here it's 11:49 p.m. No, that's UTC time, I should say. And you can see that's the data time. That's the data in there. So that's the data I'm going to look at. So this is the data that's come from Cosmos DB. So what I'm going to do is I'm going to select temperature, humidity, name, longitude, and latitude. And I'm going to turn off these prefixes, just it keeps it a bit clean. And then what I'm going to do, so that's brought in a sample of the data. And actually this database doesn't have much data in it, so it's pretty much all our data. So the next thing I'm going to do is I'm going to detect the data types in this. So what you can do is you can do this thing here called detect data types. And what that would do is look at the data and do a good guess at one thing. So it's figured out that the data type for this is a decimal number. These names over here, it's figured out it's text. Longitude and latitude, it's figured out its number as well. So it kind of does that stuff for you and just going to look at the data. So I'm going to click on Home and Apply and Close. That will bring the data into the main kind of report design for Power BI. And if I go over to the Data tab, what I'm going to do is just do a little bit of extra cleaning up on that data. So when I come to reporting, I actually don't want the sum of the data. I actually want the average. Most of the time, average makes a lot more sense, particularly for IoT scenarios. So I want the average for the temperatures flowing through. Same thing for humidity, the average. For longitude, I'm going to give it a data category over here of longitude. So latitude and longitude are known with the Power BI. So it's obviously useful for mapping. And latitude, the same deal. I'm going to click on this, and I'll go and select that as latitude, I should say. And then I can come up into the design surface. And what I'm going to do is I'm going to add a visualization. So you can see over here on the right-hand side where the mouse is, we've got visualization. And I'm going to map visualization. And I'm going to just drag that out. And you'll see over the very right-hand side, these are the fields. Remember, I selected name, temperature, and humidity, and longitude, latitude. And I've transformed that data inside Power BI. So what I'm going to do is I'm going to drag latitude and add it to the latitude field. I'm going to drag longitude to the longitude. I'm going to take temperature and I'm going to change and drag that across into the size. And you'll see, though it's not that obvious at the moment, it will become more obvious, but you can see a couple of blue circles. And those circles, in this case, are going to represent the size or the temperature. The bigger the circle, the higher the temperature, is a kind of general idea behind. And then I can come across to properties of formatting. And what I'm going to do is I'm going to just change this so that I'm just going to choose a color that pops a bit more. So we'll just make that red. I'm going to go over here and I'm going to scale the size of the bubble just to make it a bit more obvious. So I'm going to change that to 10 so you can see the data looks a bit more obvious now. I'm going to change the map style. I quite like the grayscale because it just means just makes the data more obvious what's going on. And just a few things down here. For example, I want to go and add a shadow, and I want to go and add a border, And hey, look, you can even go and make the corners nice and round and make them a bit curved. So you can see that there goes this first chart. So that's the kind of the general idea behind this. Now, the next thing I want to go and do is I want to go and add in a gauge. So I select gauge from the visualizations. I'm just going to drag this up here and just align this up. And I'm just going to put it there. And in this one here, what I'm going to do is I'm going to add the temperature to the value. So in this case here, the average temperature from these devices is 24 degrees. And I'm going to go again over to the formatting, and I can go and change the gauge. So for example, here I'm going to say, hey, look, the minimum value I'm interested in is 0 degrees Celsius. The maximum is 50. And I'm going to say, hey, look, in this factory, 21 degrees is the ideal temperature for working inside this environment. I'm just going to turn the data labels off because they're interesting for this example here. What else was I going to do? I think that was all I was going to do on that one. Yeah. And the last one I'm going to add in is a table. We'll just add a table over here. And I'm just going to add in name, humidity, and temperature for this IoT solution. And then what I want is I want all these visualizations to have the same look and feel. So there's a format there. So what I did is I selected the map one, which you saw me format. I'm going to click on Format Painter. It's the same in Word, PowerPoint, and Excel. You've got Format Painter. And I'm just going to format paint that and format paint that as well. So they've all got the same. Down in this table, it doesn't make sense to have total. Probably not interested in total. So I can come over here and turn off totals. And then finally, what I can do is I can click on View, and I can go and put in themes. And I reckoned the dark theme looked pretty nice. It did for my anyway. And you can see as I move around this report, you can see as I go and click on this, these atoms in the table, you'll see that the data moves around. If I go over to the map, you can see I can go and click on the circle. You can see I get data from that. You can also go and click on them. So they're quite interactive. The other thing that I often want to do is I want to go and put filters. In this case here, hey, look, I want to go and filter by name. Yep, I think that's where I want to go and put it. Okay, so that's kind of the general process for building up these. The next thing I'm going to go and do is publish this. And what I do now, so I've built this inside, so I'm using the desktop design. So I'm just going to save this. I'm just going to save this to the previous run through that I did on this. And what this will do now is that this will push it up to Power BI. So I've got a workspace in Power BI. And now what I can do is I can push that report, just replace the existing one that's up there. And that will take a moment or two, typically not too long. And what it's doing is it's pushing up to the Power BI web portal. And so that data's been pushed up there, that report's been pushed up there. I go and click on that, and it takes me to the Power BI portal. I'm just going to authenticate. Where did that end? Okay, cool. Let's start up a tab with my credentials for work. And you'll see that now that I've got this inside the Power BI portal. And so I can then start collaborating on them. So I can favorite it, for example. Hey, look, I'm really interested in it. I can look at my list of favorites. And I can come over here and I can share that across my organization and things like that. So that's the kind of the general idea that I can go into that data and start working with it. So it's pretty cool with what you can do in the types of reports that you can get and build. So anyway, so that's pretty much the talk. Now, I just did spot the questions and just look at it. So we talked about where is the state in 5 minutes stored. So I talked about the SQL, the stream analytics. If you have data stored in warm storage like Cosmos DB, will you flush it out to the cold storage when the new data arrives? Yes. So yes. So what you would normally do is that there is some data that you want for warm storage. You'd probably run a job once a day saying, hey, look, get rid of the data which is older than 2 weeks. Now, you might already just say, hey, look, I'm just going to make a decision. I'm going to put, as the data is flowing through the system, I'm going to put all the data into cold storage. And then I'm going to put the current data into warm storage. And I'll run a batch job once a day, get rid of the data out of my SQL database or out of my Cosmos database, and just to clean it up. So you don't want that data to be building up, because otherwise it will become too large. It'll become expensive. And of course, it will become slow if that data builds up over a huge amount, and you're trying to mix auditing data, long data, and things like that. So that's the approach that I'm going to take to them. So I don't know if there are any more questions. We're pretty much bang on time. So if you do have a question, now is the time to ask. Don't be shy. So hopefully you kind of got a bit of an idea what you can do with Power BI. And so you can do a lot. And it's pretty neat once you're going to get the kind of general gist of it. And I'll be able to shape that data for the reports. And you remember, I could do this report because I enriched that data coming up through the system. So you remember, I enriched that data with name, and you remember I enriched that data with longitude and latitude. And now I've got that data into the stream, into the data, it means I can start doing much more interesting reports and delving into the data and what it looks like. So hopefully that kind of gives you a bit of view as to how that all hangs together. Alrighty, so I know that you have another presentation, so this was pretty much bang on an hour. And so enjoy the next presentation, and thanks very much for joining in. And thanks for the questions, a good couple of questions in there, so really appreciate that. Do check out the other sessions. Remember, the other sessions, go and jump onto YouTube and go search for IoT show and ELP for the event learning path. And do follow me on Twitter. So my Twitter is dglover on Twitter, and feel free to add me on LinkedIn as well. I'm super happy to connect with you on LinkedIn as well. So thanks so much, and enjoy the rest of the event.
Thank you, Dave. Yeah, so very interesting to see the how the IoT stream data to the Azure, and then after that you show it inside the dashboard. Very, very interesting.
Cool.
All right.
Thank you very much.
Yeah, cool.
All righty. Hang up then. Enjoy the rest.
Really open and mind blowing to see the diagram that's coming directly from the device, right? So
exactly.
Cool.
Yeah. Cool.
Yeah. Thank you. So the next is Kasun Rajapakse. So Kasun, do you want to try your screen?
Yeah.
So Kasun will bring a topic about monitoring Kubernetes in Azure. So he's a Microsoft MVP. So without further ado, because we are running on time, so Kasun, your session is yours.
Yeah. I think everyone can see my screen, right?
Yeah.
So thank you for inviting for this session. So today I'm going to talk about how we can use monitoring tools to monitor the Kubernetes cluster and your microservices application, right? So this will be this session will be a very interesting one with a lot of demos, right? So if you have any questions, please feel free to ask from me. So or you can raise the hand on the Teams, right? Or you can post the questions in the chat. So when I see those questions, I try to answer it. Or after the session, you can reach to me, right? So as I mentioned in the previous, so this topic. So today's topic will be monitoring Kubernetes and what should be excited, right? So in this demo, we will go through the monitoring aspect of the Kubernetes for your application and the workloads, right? So little bit about myself. So my name is Kasun Rajapakse. So I'm a Microsoft MVP for Azure, and I am certified in Azure, AWS, and GCP, and I'm certified Kubernetes administrator as well. So I have more than 8 years experience in cloud and server technologies, right? So you can connect me on Twitter, LinkedIn, and you can visit on my blog, infracloud.com, for more about these technologies, right? Okay. So now let's go into the agenda of today's session. So first of all, I will give a little bit of an introduction about what is Kubernetes and why this technology is used to deploy applications like microservices, Docker containers, right? So then I will give you a introduction, explanation why we need to monitor those kind of applications and what are the advantages we are gained and what are the challenges we face when you are monitoring these application compared to the traditional application monitoring, right? So then we'll go into deep what are the monitoring solutions that are available for us to monitor these applications and infrastructure, right? So in there, first I will talk about what is my using Microsoft technologies, Microsoft products, how we can monitor it. Then after that, we will go through two open source products, very famous products like for Prometheus and Grafana. Then we'll discuss about Elasticsearch, right? Okay. So if anyone here who are not aware of what is Kubernetes, so I will want to give you a brief introduction about Kubernetes. Actually, Kubernetes is a very broad topic, and it will take a lot of time to give a in-depth discussion. We can go discuss Kubernetes for days or weeks, right? But in here, I will give a brief introduction. What is Kubernetes, right? So actually, Kubernetes is an open source tool that is created by Google, right? So they has a product called their internal product called Borg and Omega. So to manage their internal container platforms, so they want to give their experience to the other community. So they open source the version of their own product as a Kubernetes, right? So Kubernetes is not a very old product. It is only 5 years old because it is initially started in 2014. That means 6 years, right? So and it is governed by the CNCF, Cloud Native Foundation. And why we need to if we talk about why we need to use Kubernetes as our container orchestration platform, because it is very portable, and we can easily extend our application, and with the open source support, we can manage our containers, workloads, and services very efficiently, right? And it supports both declarative configuration and automations, right? So if you work with Kubernetes previously, you know that we need to write YAML files, and we need to deploy those YAML files into the Kubernetes clusters. So then according to these declarative configuration, Kubernetes will configure your application, and it is very highly supported for automation like Azure DevOps and other automation platforms that are available, open source and other cloud vendors as well. And it has a very large and rapidly growing community. If you go to the Kubernetes GitHub page, you can see that it is the most leading open source products after the Linux. So it has more than 30,000 stars, a lot of community support and contributors. And so Kubernetes, on top of Kubernetes, there are a lot of tools are developed by the different vendors, right? So therefore, we have a lot of wide variety of ecosystem for different products, from database to messaging monitoring, then the storage. There are a lot of tools that are around Kubernetes, right? And the more main one of the main key feature of Kubernetes is it is eliminate the manual process when you are deploying your and scaling your containerized application. Because when you take containerized applications, it is not a one single application, right? It is one single application. It is divided into small specific microservices, right? So therefore, managing those microservices will be very hard when your application grows eventually, right? So let's assume that you have application and that application, microservice application has a 100 services that are each service connected to each other, right? So imagine that managing 100 microservices will be a very challenging task, right? And scaling those microservices individually, making sure that those microservices are up and running is very challenging. So to make sure that it is happening automatically and seamlessly and reduce any manual processes, we can use Kubernetes for that. Right. Okay, so this is the Kubernetes architecture. So this is a high-level architecture of Kubernetes. So in when you talk about Kubernetes, we have two pillars. One is master nodes and worker nodes. So master node is like a brain and heart of the Kubernetes. It is managing your worker nodes and your containerized applications you deploy into the Kubernetes, right? So in the master node, I will go through these components very quickly. So in the master node, we have mainly five, we call it as a controllers, right? So one is API server, control manager, scheduler, etcd, and cloud control manager, right? So API server is responsible for managing all the APIs that are coming to the Kubernetes management. So other components in the master node are not directly talk to the outside parties. So the API server is the person who do all the API management of your cluster. So if you type kubectl get nodes, those API call is coming to the API server, then it will execute the command with the other tools, other controllers like etcd and the scheduler and control managers, right? So control manager is responsible for managing the pods and the distributing the status of the worker nodes and the master nodes. Then the scheduler is responsible for scheduling your pods into the preferred worker node, because some worker nodes may have less hardware, less capacity. So scheduler will be evaluate those criteria first and schedule the pods into the suitable worker nodes. So etcd is a very, very important component in the Kubernetes architecture, because etcd is like a I think brain, because it stores all the it's a database, key value database, and it stores all the state of your cluster and the state of your pods, and all of your entire cluster state will be stored in the etcd. So when you are deploying Kubernetes cluster, you have to be very cautious about this. It's a highly availability of the etcd, right? So in the master node, we have two components called kubelet and kubeproxy. Kubelet is responsible for scheduling the pods in the node, and the kubeproxy is responsible for configuring the network connectivity between the pods and the outside internet, right? Okay. So next we'll jump into the AKS architecture. So AKS is actually a managed service, platform as service for Kubernetes. So in this architecture, the difference is most of the things are automated. That means if you want to create an AKS cluster, from one single few command, you can spin up a AKS cluster. But if you are deploying a Kubernetes in a manual way, it is a very complex task. If you're using if you don't use tools like COPS or any other Kubernetes deployments like KubeADM, like Kubernetes deployment tools, then it will be a very complex system. So you can, if you like to take a challenge, you can deploy a Kubernetes cluster with manual. There's a GitHub repo called Kubernetes the hard way. So you can go and try out how to deploy a Kubernetes cluster in manual way, right? But in the case, what Azure done was it will take all the those difficult tasks and it will manage the master components, and as a managed service consumer, we have to take care of the worker nodes and the, your application pods, right? So a lot of troubles are a lot of responsibilities are taken care of Microsoft from the managed side, because master node is a very important component. So Microsoft will manage the master node, right? So high availability and everything will be managed by the Azure itself, right? So next we'll go and see why monitoring is very important, right? So I think most of you guys mm, work with monitoring tools, like, right? So if you're working with Azure, we have Azure Monitor, then metrics, log analytics, like it separate, and there are another tools available as well, right? So why we monitor our traditional application is we need to know what is happening on the application itself, and we need to get a visibility, right? Visibility on the application level, infrastructure level, and if there's any failures that are happening in your application or your application metrics, and if there are any failures happening on your infrastructure level, we need to know those things, right? So that's why we always implementing mentoring for our application and infrastructure, right? So we need to take a deep visibility what is happening inside your infrastructure and the application, right? So these are the few things we need to few points that why we monitor our infrastructure and application, right? So one key component is controlling resource consumption by the application or the team and the infrastructure, right? So by monitoring, we can see how much of memory is using for this application, how much CPU is using, how much network bandwidth is using for the application. Then from the infrastructure level also, we can get a lot of valuable metrics, like the total memory capacity that are need for this application, or the if you are running multiple applications, so the sum of those applications memory. Likewise, we can get a very useful visibility of the infrastructure and the application level consumed, right? So then evenly spreading application load across the host infrastructure, right? So another thing is we need to monitor is your application is when you are running application, uh, if you are getting a lot of traffic to your application, then we can see is this application need a load balancer, how we can make sure this application is auto scaling to cater that traffic. So those kind of decisions, to take those kind of decisions, we need to know the metrics and the application's behaviors, right? So one of the things, that's one of the things we need to uh, take when you are doing your application, when you're deploying applications and managing the application, right? So the next one is automatically load balancing request across the different instances of the application, right? So as I mentioned on the top, the previous point, so if you want to load balance the request from multiple application instances, then your monitoring will be very helpful, right? So monitoring resource consumption and resource limits to automatically stop application from consuming too many resources and restarting the application again, right? So those things are also very important, because sometimes when your application using all the resources in that are allocated for your uh, application from the resource end, then when the application cannot uh, uh, get more resources from the allocated resource, then it will be application will be restarting, and ultimately your application will be failing, or the your customers will be getting a errors and not responding, right? So to avoid such kind of a scenarios, we are monitoring this application through tools, and when if you are seeing that this application need additional resources, then we can allocate those additional resources accordingly to the application, right? Moving application instance from one host to another if it is a shortage of resources in the host or the host type. So it is very important, right? So sometimes your infrastructure may fails, right? So in such a scenario, if you want to migrate your application to a different host, then you need to know the metrics and the resource availability of those hosts, right? So, so for that, this is very important. So automatically leveraging additional resource made available when a new host is added to the cluster, right? So another beauty of Kubernetes is we can automatically add resources whenever the cluster needs, right? So that means if you are starting your cluster with uh, 3 nodes, and eventually you need your available resources in the nodes will be uh, reduce, and eventually it is not enough for your application, right? So when the Kubernetes identify those that for the next to deploy the next application, available resources are not available, it will go and provision another host, and it will it will allocate the pending application to the those hosts. So in to take those kind of decisions, Kubernetes and other monitoring tools need uh, other monitoring tools need metrics and those things. So it is very important monitor. Right? Easily performing canary deployments and rollbacks. So if you are using blue-green canary deployments for your application, so you can see that uh, so let's assume that you are deploying a new version of the application, and you need to test it that new version of the application to a small portion of your customers. So we can deploy it as a canary, then route small portion of your traffic to that canary, and you can monitor the that canary deployment and see what are the behaviors and what are the applications behaviors, infrastructure behaviors, those things. And if you feel that we need to do any modification, then we can easily roll back to our previous version and uh, do our carry on our production environment. So those kind of rollbacks we can use these monitoring tools. Okay. So next let's go into the what are the monitoring tools that I'm going to discuss today. So first one will be so there are three. One is Container Insights, then Prometheus, then the Elastic Stack. Right. So Elastic first I will discuss about Container Insights. So Container Insight will be a Microsoft product, right? So it is available in the Azure portal, right? So when you create a Kubernetes cluster, then you can easily integrate that cluster with this Azure Monitor Container Insight. Then you can get visibility of infrastructure and applications metrics from there. So it is supporting Windows Server 2019 and Linux as well. So you know that from the Kubernetes 1.14, Windows worker nodes also supporting in the Kubernetes cluster. Right? So the next one is the most widely used product for Kubernetes monitoring. It is Prometheus with Grafana. So I will discuss about in more detail in the coming slides, right? So Prometheus is actually open source monitoring tool, and it is built by SoundCloud in 2012, and it is the second project after the Kubernetes that are governed by the CNCF Foundation. So Prometheus is eventually matured with the Kubernetes, so it is the most preferred monitoring tool for Kubernetes. Right? Then there's Elasticstack. It is also open source products, but it has a lot of products inside this Elasticstack, like Elasticsearch, then the Kibana, then the Logstash, then the different kind of beats, right? So we can use Elasticsearch as well, and Elasticsearch has their own the paid versions as well. So I will show that one as for you. So we can use open source one or paid version as well, right? Okay. So the first one is Azure Monitor for Kubernetes. Sorry, Azure Monitor for containers, right? So in this one, we can easily use this tool to integrate our AKS cluster, right? So by 2 clicks or less than 5 minutes, you can configure Azure Monitor for containers, right? So by this tool, what will happen is it will identify your AKS containers and running container nodes and their average processors and memory utilization. So this can help you guys to get a visibility of your infrastructure and the containers resource allocation. So if you see any bottlenecks on your infrastructure or containers, then you can take action based on this, right? So other other point that Azure Container Monitor Container gives you is it'll see how the pod overall performance and the controller details. That means if you work with Kubernetes, you know there are different kind of controllers like deployments, replica set, daemon set, stateful set. So with those things we call as controllers, right? So these controller status also can be checked from the Azure Container Monitor, right? And it also support Azure Container Instance. So it is a hosting your single containers as a platform as PaaS service. So it also support container instance as well. So another thing is you can review your resource utilizations and average memory CPU utilizations for your pods. And another thing from this tool we can see is the logs. That if you have a standard out is configured in your Kubernetes pods, you can easily see the standard out of the Kubernetes. Those pods, right? And Azure Container support for exporting your container logs to the Azure Log Analytics workspace and your cluster logs to the Log Analytics workspace as well, right? Okay. So before I go to the demo, so do you guys have any questions for this until now? Okay. So if you don't have questions, I will jump into the demo, right? So I hope you can see my screen. Okay. Okay. So in this demo, I already created clusters in my subscription, right? So if you want to create a cluster, it is not a very complex task in Azure. So if you can use Portal, or you can use ARM templates, Terraform, API, Azure CLI, or all the available, most all tools available. So you can choose one of your preferred to deploy cluster. Right? So I already have created a cluster called SG IT Pro AKs, right? So if I go to this cluster, under the monitoring insights, right, you can see these graphs, right? So these are configured by when I'm deploying the cluster, right? So these graphs are populated with the log analytics workspace, right? So when you deploy a cluster in Azure with the Kubernetes, so it will create a log analytic workspace, and that log analytic workspace is connected to the AKS cluster. So then whatever the metrics will be shipped into the AKS cluster, log analytic workspace, then from the log analytic workspace, these dashboards will be shown, right? Okay. So you can see the overview in the overview of the Kubernetes cluster under the integrations, container insight is enabled, and you can see the workspace here. So if I go to the workspace, you can query the workspace and get the relevant metrics in the workspace itself, right? So let's go to the insight. Then here you can see the cluster-wide CPU utilization, then the cluster-wise memory utilization, and the node count on your cluster, right? And how many pod counts, right, in your cluster, right? So available pod. Then you can see the node wise as well. So you can see the metrics in the node wise. So you can see the uptime here. Then the memory utilization, containers that are in each node, and uptime as a bar chart. Right? So if you drop down these one node, you can see the controllers and containers that are running on each node itself, right? Then controllers, I told you about daemon sets, replica sets. Then the deployments, those are we call controllers. So the controller status as well shown here, right? Then the individual container wise also you can see. So you can see their trends and CPU utilization and memory utilization available there as well. Okay, right. So if you click one container, then there's a view live data still in a preview. So if you click this one, it will show you the standard out here. If there are any standard out data is there, I think this one is standard out, so it won't show you any data, right? So you can see the standard out there. So if you click container, you can see the container details and CPU limits, requires memory limits, and then the environment variables as well. Okay, so then that alerts, so you can configure alerts based on those metrics, right? So then you can use the available metrics here, right? Container wise or custom metrics that are available here. And you can always use the log analytics queries, right? So there are pre-built queries here, so you can use it, or you can create your own query here. Right? Okay. Okay. Now let's go into the slides. Okay. Okay, so the next I will discuss about Prometheus and Grafana, right? So as I mentioned in the introduction, Prometheus is one of the leading monitoring tool for the Kubernetes because it is there from the beginning of the Kubernetes, and it is based on the Google's monitoring tools Bogmon, right? So it is originally developed by the SoundCloud in 2012. Then it is publicly launched in 2016, right? And it is not written in Go language and open source monitoring and very uh, I see very solid monitoring and LT system, and it is not only for the Kubernetes or containers. It can be used for lot of other uh, applications as well, like for database monitoring, like MySQL. Then if you have you can use Windows monitoring as well, and there are a lot of export as we call. I will when I'm discussing about architecture of Prometheus, I will discuss about exporters. So there are a lot of exporters for different technologies. So you can use those exporters to export data from those applications or metrics, and you can use those things to monitor your infrastructure and another good thing about it is uh, Prometheus has their own SDK. So if you wish to monitor your application with the Prometheus, you can configure the Prometheus in your application to export different metrics as output from your application. Then Prometheus can grab those metrics, and you can use Prometheus to store those metrics and monitor them. So Grafana is also is a visualization tool, very famous visualization tool. It's also open source, right? So we can integrate Grafana with Prometheus, then a lot of other tools as well. So because of these two are open source, most of the people are using these tools for their monitoring of Kubernetes and those containerized platforms, right? Okay, so this is the architecture of Prometheus, right? So when you deploy Prometheus into your Kubernetes cluster or any any infrastructure, right? So we have first we have to deploy a Prometheus server, right? So Prometheus server has the time series database, that's what you call TSDB. It is not like a SQL or any other database. It is a separate database kind that are uh, created for the monitoring time series monitoring. So this time series database is connected with push gateway and the exporters and the jobs. So what time series database do is these pull metrics will be pulled from these jobs and exporters or push gateways, and it will store in this time series data. Then this time series data can be used to do create alerts through alert manager. It is also Prometheus product. So by using alert manager, you can integrate PagerDuty, emails, Slack, Opsgenie, or there are a lot of webhooks. There are a lot of tools that are supported for alert manager. So you can create a trigger the alert based on the time series database data. So you can trigger if there's a memory alert or CPU alert, you can easily trigger it from the alert manager based on the Prometheus time series database queries, right? So I told you about exporters, right? So these are the Prometheus targets that can be configured with Prometheus server. So we can use multiple targets, multiple exporters, multiple jobs to scrape. We call it as scraping data. Scraping data from your target systems and then pull those metrics into the Prometheus server and stored in the time series database, right? So there are a lot of exporters available for MySQL, Nginx, Kubernetes, Windows, there are another products. So you can use those exporters and configure it in those target environments, and you can push those data to Kubernetes. Sorry, Prometheus. So then we can use alert manager. Then the alert manager configuration we can say based on the Prometheus query, you can trigger the alert, and you can send the alert to your email through email, or you can use opt-in if you are using incident management systems, or by using webhooks, you can trigger the alerts. Right? So this Prometheus query language, we call it as a PromQL. So this PromQL is the main source of creating these alerts and the dashboards, right? So visualization, when you come to the visualization of the this data, we have Prometheus Web UI, but it's not a very rich UI. We are using it for the testing the queries and getting data. The mostly used visualization tool is Grafana. So we can use Grafana to visualize your data, your metrics data in very detailed manner. So I will show you how to dashboard. I will show you some dashboards in Grafana so you can see how detailed those dashboards can be configured, right? So this is the high level of the Prometheus architecture. So if you are using Kubernetes, you can use service discover to discover the targets, right? Or by using the Kubernetes configurations that are configured in Prometheus. Okay. So let's go into and see how we can work with Prometheus. So I will show you how to create a how to deploy Prometheus in Kubernetes, right? So if you work with Helm, Helm is a Kubernetes package manager. So that means if you want to deploy applications into Kubernetes, most of the people, what they do is they package the application through a Helm, and by using Helm command, they deploy the entire application stack into the Kubernetes, right? So it is very easy. So by using values files, you can change whatever the parameters you need to deploy, right? Okay. So first thing is I will log into my subscription. So I already have a Kubernetes cluster created, so I will switch it to the that cluster. Okay. So first thing I will log into the Azure. I will set my subscription. Done. Okay, I already done do these two. So if you want to create a cluster, you can first create a Kubernetes, resource group. Then you can use the ACAK's create command, and you can create a cluster. So I already have my credentials. So to work with Kubernetes, you need to download the credentials to talk to the Kubernetes API server. So I already have it. So I will type kubectl get nodes to check it. Yeah. Okay. So in here, what I'm going to do is I will use the low-key stack. Actually, low-key stack is another extended version of Prometheus, Grafana, and Loki. Loki is a product that uh, created by the Grafana people, Grafana team. So Loki, because Prometheus is not a log collection platform, right? So it is only a time series data metrics storing platform, but they don't have any log collection platform. So they create a product called Loki. So Loki is the log collection platform for your applications and cluster infrastructure. So in this demo, I will deploy a entire stack with Loki, Alert Manager, Prometheus, Grafana, and push gateways, everything, right? So first I will add the Helm repo, right? Then I will update the Helm. I already done it, but to the safe side, we'll update it again. Okay. So let's see, I have the namespace. kubectl get ns see no the log yes log stack is already created, right? So I will use this helm command to deploy the the entire stack, right? For that one, I will use install helm install. So from the helm install, I am giving a name of the helm deployment. Then I'm giving the helm repository. Then the namespace to deploy, and I'm putting setting some values there, right? So so in here, what I'm doing is I'm enabling the Grafana, Prometheus, then the alert manager. Yeah, I'm enabling Grafana Prometheus. Then I'm using enabling the using of persistent volume for the Prometheus alert manager and the persistent volume for the Prometheus. Then I'm going to enable the persistent volume for Loki and specify the persistent volume class and the size of the volumes, and Grafana server persistent volume also enable, right? So I'm going to select this one, then copy it and deploy it, right? Okay, so it is deployed. So let's go and see if it is. Okay, so you can see that now the containers, the relevant the workloads are creating, right? So Loki to create the Loki, it will take a little bit of time because it is creating as a stateful set. So it will take 1 or 2 minutes. So others are already created, right? So you can see the from tail, then the Prometheus server is starting, push gateways, alert managers, and everything is starting. Right? Okay. So I'm not going to wait until this one is uh, creating. So I already have a environment that I created previously, right? So let's go and see. Keep CTX. Switch the context. Okay. Okay, here you can see that I have the same stack here, right? So under the low key, you can see a lot of pods are deployed, right? So these pods have their specific purposes. So alert manager is used for alerting. Then cube state metric is used for getting the metrics. Then the Prometheus server it is running, and the Grafana is running, and the Loki is running as a uh, uh, stateful set, right? Okay, so now let's go and see the dashboards, right? So in this demo, what I do is I have configured my Kubernetes cluster with ingress controller and the cert manager. So therefore, I have my own domain names, right? If you don't have that, if you didn't configure the ingress controllers and the cert managers, right? So then you can use these commands, right, to port forward your service, and you can access those Grafana, Prometheus, and alert managers through the local host. Right? In the case you don't have the didn't configure the those ingresses and set managers, right? So this is the Prometheus dashboard. So I told you about. So here you can see you can type your POM-QL expression here. So if, for example, if you want to take memory, so you can see there are a lot of metrics available for nodes in the containers likewise, right? So let's see node type like this. Node memory. Yeah, there are a lot of node memories. Activity bytes, right? So then you can see these values, right? So these are time series value. So these two values must be converted into some other formats, right? So you can use sums, and there are a lot of expressions. So by using those expressions, you can create a very meaningful dashboard. So I will show you these expressions in the Grafana. So then in the graph, you can see these data, right? For each node, because we have three nodes, so you can see 3 nodes data, right? Okay. So then let's jump into the Grafana. So this is a Grafana implementation. So I have a few dashboard with me to show you guys so how awesome it is. So this is one of the dashboard, right? So here you can see the entire cluster state, right? So how much of CPU is using, how much of memory is using, then pod-wise memory, then the pod-wise CPU, then disk usage, and total how much memory do you have, how much use from this total. Those everything will be shown here, right? So let's go for another dashboard. Now this is another one. right? So can get in detail data. So this is one of the good dashboards, right? So you can see node wise, deployment wise, right? Pod wise, container wise, and network. We can get a lot of useful information from these kind of dashboards, right? So when you are doing troubleshooting your application or infrastructure, these are will be very helpful for you to do this, right? Okay. So next I will show you the alerts. So here in the before I go to the alerts, so I will show you the how the service Prometheus will get data that I told about exporters and jobs, right? So in the Prometheus status, you can see the targets. So these are the targets that are uh, pushing data. So these targets will be push data to the Prometheus. So then if you want to troubleshoot these things, if you can see these some targets are down, that means something wrong with those targets, and you can troubleshoot them, right? So configuration. So this is the configuration of Prometheus. So it is totally written in YAML. So there are no UIs. So you have to configure your Prometheus configuration through YAML file. So these YAML configurations are available in the help of the Prometheus documentation. So you can refer those things, right? So this is one for Kubernetes uh, jobs, right? So you can see each one has their separate jobs. So these jobs will be pushing data to the uh, Prometheus to the targets, right? So now let's go to the alerts, right? So these are the alerts I configured for my environment, right? So you can see disk pressure. So then if you take a disk pressure, you can see the alert name, then the expression. This expression is actually a Prometheus ProbQL expression. So you can create whatever the ProbQL expression and you can use it as a alert. So then there's a label like critical severity, then annotations you need to put to these um, alert, right? So there are a lot of alerts available. These are for my nodes, these are for my pods, and these are for my Prometheus itself. I need to configure alerts. Otherwise, if there's some target is missing from my Prometheus environment, then I should know that. So then there's a SSL certification alerts as well, right? So in the alert manager is a place we use to uh, push alerts to these other alerting tools like PagerDuty, then Opsgenio, Slack, Mails, right? So currently I don't have any. I need to run it on the localhost. Right. So let's see. So under the status, you can see the status of the alert manager and the configurations, right? So here you can see I have my SendGrid account configured, right? And I configured a route for that one. Then I'm specifying what are the alerts you need to route it from this email in the email receivers. So I have configured those alerts as well, right? So then the receivers, I will specify the email configurations for my receiving one, right? So those objects and those things you can configure as it is yourself, right? Okay. So next I will go through the next I will jump into the Elastic Stack, right? So we have a little bit of time. So Elastic Stack is an open source one. So it is created by the Elastic group, right? So it is also like a Prometheus and Grafana like visualization tools, right? So it also has a lot of uh, tools are available for monitoring different platforms, not only Kubernetes, like Nginx, then the SQL databases. Likewise, there are a lot of options there, right? So you in the Elastic, they are using something called beats. There are file beats, metric beats, journal beats. Likewise, there are different kind of beats types. So we can install those beat types on your environment, then configure those beats to ship the uh, those data into the Elastic Stack. Then from the Elastic Stack, you can visualize it from using Kibana. Right? So this is a high-level architecture of the those Elastic Stack architecture. So you can directly push logs to the Elasticsearch through the beats. So you can use a log stash in between. So if you're pushing lot of data like large amount of data, then it is best to use the log stash in the middle of Elasticsearch. Then from the Kibana, you can use Elasticsearch as a querying platform, and you can visualize this from the Kibana. So I will show you the Elastic Stack as well for you. So how many of you guys know that there's a in Azure we have the managed service offering for Elastic Stack. It is not available for previously. It's not available. So if you search Elasticsearch, I think you have to go to the marketplace. Yeah. If you search for Elastic, so you have two options. You can use Elasticsearch self-managed, that means VMs that you need to manage, and there's another version for cloud, Elastic Cloud. So this one will use a pay-as-you-go method, and it is using Elastic Cloud to deploy the infrastructure, and it's very easy. So you can easily, you don't have to manage the infrastructure behind the Elastic environment, right? So you just go and create a cluster. So then you can monitor your Kubernetes and other applications and platforms to there. So this is my Elastic. This is my Elastic cloud environment, right? So if you go there, then you can see the entire structure architecture is deployed on the cloud, right? On their cloud, right? Then we can use Kibana launch to launch the Kibana, like right here. But in this environment, I didn't configure any dashboards or anything. But so in here, I'm using metric beats. So to get the metrics data of the cluster. So if you go to here, you can see the metric rate of my nodes. Then if you select pods, you can see the pod metric rate as well, right? So if I go to my cluster, there's a daemon set running as a metric bits. So these daemon set will be pushing data to the um, Elasticsearch cloud, right? So by using that one, it will grab the cluster level data, right? Okay, so a few other tools that you can check is Container.io and the QBS, then the Rancher and the Istio, right? So Container.io and QBS I can show you now. So it is also like a monitoring platform tools, right? Monitoring and managing, right? So here you can see the dashboard. Yeah. So you can see the cluster configuration files, then the applications that are running there, then the volumes that are provisioned in the cluster. So then if you go to these each things, you can see the events in the YAML for that one. So these are very well things can be shown, can get the visibility of the cluster itself, right? So QVice is another, it's like a security tool, so you can see how what are the configurations mistakes you have done and those things. So when you drop down these things, you can see different alerts, right? So you can use role editor to create roles based on these alerts, right? So you can go on these tools by your own, so you can learn more about these tools. And there are a lot of other tools. So if you go to the CNCF Foundation, right? So under the monitoring, you can see the Prometheus is the graduated one. Then there are Cortex, Thanos that are incubating. So the Cortex and Thanos both are based on the Prometheus, and there are other observability and the analysis tools like Grafana, Weave Cloud, Datadog, very famous ones, Sysdig, then New Relics, Kiali is for Istio. So there are a lot of other tools, Log.io, then Fluentd, Jaeger, those are there for logging and tracing. Okay, so I think that's all for my session today. So if you have any questions, you can ask from me. Any questions?
Any questions? Any questions here? I think there's a one question. What is the main difference between, I don't know if you already answered, three monitoring solutions?
Difference between three monitoring solutions, right?
Yeah.
Yeah. So the difference is actually in the Azure container is integrated with Azure, so it is not a third party one, right? So it is based on the Azure Organics workspace. And when you talk about the feature wise, Azure Monitor is a little bit behind compared to the other two platforms, because Prometheus and Elasticsearch has a very broad uh, way of using logs and metrics, right? So actually there are no significant difference between the Elasticsearch and Prometheus, right? But most of the people are used to use Prometheus because it is open source with Grafana. So Grafana is open source as well. And Prometheus is more flexible compared to the Elasticsearch, because Elasticsearch, to learn Elasticsearch, it is a very complex system, right? So you need to have invest a little bit of time. There are a lot steep learning curve. So compared to the Prometheus. So Prometheus we can easily learn and easily configure uh, with Grafana and those things, right?
Okay. Any other questions before we? Come on, you can unmute yourself. You want to ask question directly? All right. So before we end this meetup, I will also want to announce a couple of upcoming sessions that we will have. So we will have Kubernetes sessions. The time is still TBC, and then we will have a AI ethic for the AI practitioner, and then the next also upcoming is very close. This weekend we will have a M365 bootcamp, developer bootcamp. So if you want to learn about the M365 on the adaptive cards, please join the sessions Saturday morning, right? And then we will have also the SQL Saturday. Oh, this is also the same thing together. Right. So if no more questions, anyone want to raise the last questions before we close this? No more. Just please don't forget to subscribe to our YouTube channel, and this is the QR code. So please subscribe. Please share if it is useful. Share with other and invite the other people to join our meetings. With that, thank you for your attending these sessions, and we'll see you the next time. Good night. Oh, yep. Good night. Thank you.